Hello student, this is a continuation of our previous part in which we studied about the reflection of light. So in this video, we will study about the spherical mirrors and how the image is formed in the spherical mirrors. So we can start now. So first thing, what is a spherical mirror? So we can define it as a mirror whose reflecting surface is curved. So there are two types of a spherical mirror. First is convex mirror and concave mirror. Suppose if I take a sphere and cut this sphere into two parts. Let us name this first one as part 1 and the second one is part 2. So here this part 1, if I represent it, and we make the one side as non-reflecting side. So this is a convex mirror. Now we take the second surface of the sphere. So it will be, and in this case we make outer region as non-reflecting surface and inner is the reflecting surface. So this forms a concave mirror. So let's try to understand more about the concave and convex mirror. Let's start with convex mirror. So the reflecting surface is curved outwards and it is diverging in nature. Similarly, if I see the concave mirror, the reflecting surface is curved inward and it's a converging in nature. So here we need to understand what is the meaning of diverging and converging. So let's take a example. If I have a concave mirror and we try to pass many rays through it. So what we will notice, all the rays will conserve and they will meet at a point. Similarly, if we are using a convex mirror and we take many incident rays, so what we will notice that all the rays will diverge. So that's why convex mirror is a diverging mirror and concave mirror is a converging mirror. One more thing I want to explain how this converging and diverging rays are formed. Okay, so let's look into it. Let's take an example for a convex mirror. Here, if we take the incident ray, so what will happen if I zoom it? What will happen? The normal will form in this direction. So as we know, a spherical mirror will also follow the law of reflection, and according to the law of reflection, this is the incident ray. So what will happen? Incident ray is equal to the reflected ray. So it will reflected ray will go in this direction and this will become reflected ray. If same way we take another example like here we take one more incident ray. So what will happen? This is the normal. So it will go this way. So incident ray, this is the incident ray and this is the reflected ray. So here reflected ray is diverging in nature. If we take the example for a concave mirror, so in that case, this is our concave mirror. In that case, if this is the incident ray, so here normal is, this is our normal. Okay. So what will happen? This is our angle I. So angle R will be in this direction. So what we noticed? It is converging in nature. Concave mirror is converging in nature. I hope you understood this concept properly. After this, we will move to the some common terms used in the spherical mirror. So first is pole. It is the center of the spherical mirror. So here in concave mirror, the center of the spherical mirror is represented as P. For the convex, here we can put the pole. That's the center of the spherical mirror. Second is center of curvature. It is defined as the center of the hollow glass sphere of which the mirror was a part. So here, what is the meaning of it? If this is our concave mirror, and if I try to make a sphere, the center of this sphere is called as center of the curvature. Similarly, if we have a convex mirror and if we try to make a sphere, the center of the sphere is the center of the curvature, and it is represented as capital C. Next term is radius of curvature. The distance between the pole and the center of curvature is called as radius of curvature. It is represented as capital R. So if we have a concave mirror and this is the pole and here is our center. So the distance between center of curvature and the pole is called as radius of curvature. Principal axis. The line joining the pole and the center of curvature is called as principal axis. So here, this is our concave mirror, and here is the pole. This is the center of curvature. The line that you here notice, this line joins the center of curvature and the pole. This is called as principal axis. Similar way, we can represent in the convex mirror. Here is our pole. This is center of curvature, and the line that passes through pole and the center of curvature is our principal axis. Next is principal focus. The point on the principal axis where all the parallel rays actually meet or appear to meet after reflection. So let's understand this principal focus. If I take a concave mirror, this is our principal axis. Here is the pole. Here is the center of curvature. So if we take an incident ray that is parallel to the principal axis, then on the surface it gets reflected and pass through the principal axis. Similarly, if I take another parallel ray, so what will happen? It will again reflect. Because it is a concave mirror, so concave mirror is converging in nature. So they both will converge and meet at a point on the principal axis. This point of intersection on the principal axis is called as principal focus, and it is represented as capital F. Similarly, if we use a convex mirror, and here is a principal axis. So what will happen? This is the pole, center of curvature. Two rays we can take and both must be parallel to the principal axis. So what will happen? We know that it is a convex mirror. So convex mirror is diverging in nature. So both will diverge, and after diverging, and both will meet at a point on the principal axis. This is principal focus. I hope you understood this concept properly. In ray diagram, we commonly use this concept, these ray diagrams. So next is focal length. Focal length is the distance between the pole and the and the focus. So here for concave mirror, if this is the pole, here suppose this is the focus. So the distance between pole and the focus is represented as focal length, and it is the small f. Similarly, for the convex mirror, this is the pole, this is the focus, and the distance between pole and the focus is focal length, small f. Next is aperture. It is the effective diameter of the spherical mirror. Means if we use any sphere, any spherical mirror, so whatever the diameter of it, that is represented as aperture. So there are total 7 common terms we need to remember. But when we remember, we need to understand the concept because it will be always used in this topic. I hope you understood this concept properly. Then we can move to the relation between the focal length and the radius of curvature. Focal length is represented as a small f and radius of curvature is represented as capital R. So see what here we noticed. This is our concave mirror. This is the principal axis. Here is the pole. This is the focus. And this is the center of curvature. So focus lies between center of curvature and the pole. It means that radius of curvature is double of the focal length. So what is the relation between radius of curvature and the focal length? Radius of curvature is 2 times of focal length. It can be also written as focal length is half of the radius of curvature. In numericals, we can use this relation when we need to solve the problems. Next is rules of image formation. There are few rules that we will apply in the image formation. So rule number 1, when the incident ray is parallel to the principal axis, after reflection, reflected ray must passes through the principal focus. So what is the meaning of this rule? It says that if we are using any spherical mirror like concave and convex, and this is our principal focus, F pole center of curvature. If we take any incident ray that is parallel to the principal axis, it must passes through focus after getting reflected. This is the rule number 1, and it is also applied for the convex mirror. So this is our convex mirror. Here is the principal axis, pole, focus, center of curvature. If we take the incident ray that is parallel to the principal axis, we know that it is diverging in nature. So then after that, it will pass through the focus. This is the incident ray. This is the reflected ray. Let's move to the rule number 2. Rule number 2 is actually the reverse of rule number 1. It means that when the incident ray passes through the principal focus, after reflection, its reflected ray is parallel to the principal axis. So as I told, it is a reverse of rule 1. So here, this is our concave mirror, principal axis, pole, focus, center of curvature. If the incident ray passes through the focus after getting reflected, reflected rays parallel to the principal axis. Here, this is the incident ray and this is the reflected ray. Similar way, we can draw it in the convex mirror. This is pole, focus, center of curvature, and here is the incident ray which passes through focus. After reflection, it will become parallel to the principal axis. If you have any doubt in this video, you can clear your doubt in the comment box section. I will try to help you. Next rule is, which is the rule number 3. It says that when the incident ray passes through the center of curvature, after reflection, reflection, it bounces back in the same path. So what is the meaning of this rule? Let's take an example. If we have a concave mirror, this is the pole. Here we can draw a focus, and this is the center of curvature. If we take the incident ray that passes through center of curvature, so it will go touch the surface and bounces back in the same path. So what is the reason behind that? In part 1, I explained you about the plane mirror. In that, I was telling you that when the incident ray touches the surface and it is perpendicular to the surface, so it will bounce back in the same path. So there I explained you it happens because normal is perpendicular to the surface and incident ray is also perpendicular to the surface. So it means that normal and incident ray both coincide with each other. So here angle I will be equal to 0. So from the law of reflection, if angle I is equal to 0, it means that angle R will also be 0 because law of reflection says that angle I is equal to angle R. So that's why incident ray and reflected ray both lies in the same path. Same case here in the center of curvature. When the incident ray touches the surface, so in this case normal and the incident ray both coincide with each other. Like this is our normal and here is the incident ray. So same logic applied what we studied in the part 1. Okay, so that's why reflected ray will follow the same path. I hope you understood this part clearly. Similarly, if we use a convex mirror, so in convex mirror both focus and the center of curvature lies behind the mirror. So that's why they are imaginary. So if we take the incident ray, so incident ray and reflected ray both lie on the same path. So these are the three rules. One more rule is, which is rule number 4, when the incident ray touches the pole, it gets reflected and principal axis behave as a normal. So this is rule number 4. If we have a concave mirror, pole, focus, center of curvature, if the incident ray passes through the pole, it reflects. This is our angle I, angle R, and principal axis behave as a normal. Same thing applied for the convex mirror. This is pole, focus, center of curvature. incident ray, reflected ray, and this is the normal. Principal axis behaves as a normal. So this is our total 4 rules that we will use in the image formation. So let's start image formation in the concave mirror. So there will be 6 positions of the object. So what are the positions of object? First is object is at infinity. Second, when the object is beyond center of curvature, that is capital C. Third is when the object is at center of curvature. Fourth position is between center of curvature and principal focus, or you can say between C and F. Fifth is at principal focus. And the last, which is the sixth one, between principal focus and pole. So we have to know all these 6 image formation in concave mirror. So let's start with the first one, when the object is at infinity. So our first one is at infinity. So when the object is at infinity, incident ray is parallel to the principal axis. So here in image formation, we will always take the 2 incident ray. Like here in the first one, at infinity, we draw a concave mirror. This is our principal axis. Here is the pole, focus, center of curvature. As I told, when the object is at infinity, we have to take the 2 incident ray. And in infinity, both the incident rays are parallel to the principal axis. So here I am taking one of the incident ray. So if you remember in rule number 1, when the incident ray is passing parallel to the principal axis, it must pass through the focus. This is the rule number 1. So this is the ray 1. Let's take ray 2. This is also parallel to principal axis, so it must pass through the focus. So where both the incident rays are meeting on the principal axis, there the image is formed. In this case, image is formed at focus. So nature of image will be, first, it is highly diminished. Why it is highly diminished? Because image is a point. Image is a point. Here the image is present. It's a point. Okay, so that's why it is highly diminished. Second is, it's real and inverted. Why it is real and inverted? Because both the object and image are in the same side. So in mirror, when the image and object present in the same side, so it will be real and inverted. Third is, image is formed at F. At F means principal focus. So this is our image formation when the object is at infinity. Let's move to the second image formation. When the object is present beyond C. So we can draw a concave mirror, principal axis, pole, focus, center of curvature. And here is our object. This is the object. So on this head, both the incident ray will start from the head. Like one, I can take it as a parallel to the principal axis. Where it will move, it will pass through the focus. That is rule number 1. Second is, we can take through the pole. So here this is our image form. Both the reflected ray will meet between C and F, and it is diminished, not highly diminished, but it is diminished, and it is real and inverted because object and image both are in the same side. So what we can write the nature of the image? First, it is diminished. Second, real and inverted. Third, image formed between C and F, means center of curvature and the principal focus. Now let's move to the third case. Position of object is at center of curvature at C. So here this is our concave mirror, principal axis, pole, focus, center of curvature, and here is the position of object. So in all the cases, I will take two rays where one will be parallel to the principal axis, and according to rule number 1, it must passes through the focus. Second is, when the incident ray passes through the pole, center of curvature behave as a normal. So why I will take these two rays only? Because it's easy to remember. So in exam when you will draw, you will feel more confident. So what is the nature of image in this case? First is size of image is same as size of object. Second, real and inverted, because both are in the same side. And third is image formed at C. When the object is between C and F, means between center of curvature and the principal focus. So here is a concave mirror, pole, focus, center of curvature. This is our object. So similarly, we follow the two rays. One is parallel to the principal axis. It will pass through the focus. And second is, it passes through the pole when the incident ray passes through the. Nature of image in this case is, it is magnified Second, real and inverted. Third, image is formed beyond center of curvature. Next is when the object is at F, means at focus. This is our concave mirror. This is the principal axis, pole, focus, and center of curvature. So at focus, we take a object and two rays we will take. One is parallel to the principal axis, so it must passes through the focus, and second is through the pole. So in this case, what we will notice, both the reflected rays are parallel to each other. So we assume that parallel rays always meet at infinity. So here image will meet at infinity. So what is the nature of this image? First is highly magnified. Second is real and inverted. Third is image form at infinity. So these are the nature of image when the object is at infinity. Then there is one more, when the object is between focus and the pole. So this is a special case. Why it is a special, we will see. If we take a concave mirror, this is the principal axis, here is the pole, focus and center of curvature. So between F and P, we put the object. And same rules we follow. One is parallel, it passes through focus. Second is pole. So you see, both the reflected ray are diverging in nature. So anything which is diverging in nature, it means that there must be some source from where it is coming out. Like let's take us example as a point source here. So what will happen? If we take two rays, one is going this, another is following this path. So these rays, when it is going away, what happens? The gaps are increasing. It means it is diverging. It is diverging in nature. Okay. So same way, if these two rays are diverging, it means that there must be a some source from there it's coming out. So we assume that if we stretch this incident, this reflected ray, so here is our point. Let's assume as O. So here is our image is formed. I hope you understood this concept. My point was when anything is diverging in nature, so there must be a source point from where it started getting diverged. So here point O is our source point from where these two reflected rays are getting diverged. So what is the nature of image? First is it is magnified. Second, virtual and erect. Why it is virtual and erect? Because here image and object both are in the different sides. And third, it is image is formed behind the mirror. So let's quickly summarize the ray diagram of concave mirror. So what happened? What happened? See, if you understand this, it's easy to remember. When the object was at infinity, when the object was at infinity, image what at focus. If you reverse it, object is at focus, image is at infinity. Similarly, when the object is beyond C, image is between C and F. Reverse, when the object is between C and F, image is beyond C. So these four cases are very simple. Next, when the object is at C, image is at C. So here, this is the one part. Second part, you notice when the object is at infinity, that time image is at focus and it is highly diminished. Means if suppose this is our infinity size of the object, then the image size at focus is dot. But when this object is moving towards the center of curvature, the image size increasing and it is moving away from the pole. Image is going away from the pole and the object is moving towards the pole. At center, what happened? Both will become equal. Image and object both will become equal. And then after that, when the image moving from center of curvature, it will become magnified. And the object, obviously, it becomes diminished. And at focus, object is highly diminished and image is highly magnified. Only between F and P is a special case that forms the virtual image. Okay, fine. So one thing you will always remember, what is that? In plane mirror, virtual image is formed and it is on the of the same size. But in concave mirror, when the virtual image is formed, that time it is magnified. So many times one marker question comes based on these small points. So you need to remember. So in this video, we have stopped till here. In next video, we will continue with the convex mirror, and we will also understand about the mirror formulas, and we will solve some problems. Thank you so much.